Okay, good morning from my side. My name is Ioannis Vasalos from National Center for Scientific Research Demokritos, and I'm going today to present the part of the base part of the cybersecurity core, which has the acronym Pre-Assessment and Stress Testing in 6G, which is the second major innovation that our project proposes. Okay, so the outline of the presentation is a brief presentation complementary to what has been presented so far about the MARE project, a small introduction again already presented for the security plane, and then going to the pre-assessment and stress testing philosophy and inputs, architectural design, the validation context, the test environment management, and the pre-assessment and validation. So from the MARE project, from the paste perspective, as it has been presented before, is to provide a secure 6G services provision framework. The paste context is that we want to have a well-defined set of open programmable security functions that the paste module can instantiate and stress test as testable artifacts rather than test configurations. So to be able to test thoroughly what the security functions may provide while offering cybersecurity solutions. These are delivered as enablers to 6 architecture, with the paste component validate them across transparent, multi-domain stakeholder environments before enforcement. So the idea here is that we don't know, the 6G architecture is still in its infancy. Nothing has been finalized yet. It's supposed and it's planned to be really modular and really elastic. So we need to be able to cater for that. And finally, through the paste component, have the ability to proactively propose and assess strategies against novel attacks and threats. So the paste will be able to supply the evidence, replaying candidate security function in simulation, emulation, or real infrastructure, and score them against SSL and SLO criteria that I will explain further. So the idea behind here is that since 6G will be, it's really novel, it's predicted to have a really vast threat area. So we need to be able to adapt on this, adapt dynamically to the threats that may occur in the future. So, as has been presented before, the MARE cybersecurity plane consists of the interface layer, the main cybersecurity core, and the abstraction layer. The philosophy of the paste is that the MARE as a solution should be modular and adaptable in the sense that any security function composition can be instantiated and tested on demand. And it needs to integrate heterogeneous data, so data from telemetry, from a vast, as I said, 6G network architecture, characterization baselines based on the network functions and network services that will be offered in the 6G network, and new and not yet, let's say, known threat models. And this it needs to be fed into the paste and along with the cybersecurity core, come up with a cybersecurity solution. So the core idea behind paste is that an automated security plane is only as trustworthy as the evidence behind its decisions. So the paste produces that evidence before any action is applied to the network. So any security function that will be designed needs to be thoroughly tested before in another context, in a context not like affecting a real network, in order to be proven that it applies and it is valuable to the network, so it can be useful and not catastrophic. So the design pieces of the paste component is that we need to validate before enforcing, so no automated security action reaches production untested. We want to have various fidelity levels, so from simulation, emulation, or real infrastructure. This is chosen for assessment scope, depending on the data depth and granularity needed in order to compose a valuable security function. This security function needs to be policy-based design, so it needs to adhere to the security service levels agreements that need to be, that our security function needs to be compliant to the network service provided. We want to have reactive and proactive mitigation. So we need to have the capability to stress test against possible or predict threats before they occur. So even not detecting, but sort of preventing possible occurrences of attacks, and have one methodology. So only differences in configurations regarding our security functions capable of being like adaptable to any workflow, to any 6G security architecture. So the philosophy of PACE is to have proactive validation, making automated 6G security trustworthy. So the PACE input from the MARE security plane. The philosophy of the PACE component is for PACE to be a consumer of the whole security plane, so not taking decisions alone. So from the cybersecurity core, as was presented before, from the adaptive security policy orchestration, we get the candidate mitigation security functions and playbooks, the security functions to be composed. From the abstraction layer, we get the telemetry metrics as an assessment baseline, the system characterization profiles to steer the context selection, so which sort of context we will use, and the attack surface identification threat model as the scenarios. From the interface layer, we get the security service level agreements as what needs to be, what is the, let's say, the contract that we need to protect. So the policy that we have, the security layer objectives, and the acceptance criteria. And what is returned from PACE is the assessment verdict and the evidence to the attack to adaptive security policy orchestration, if it is compliant, in order to be implied and applied to the network. So on the right side of the presentation, you see the components that have been taken. It's a platform, as we say, that collects all this data in order for this data to be utilized by the test environment manager and the pre-assessment validation to assess the security function and provide evidence if it's safe to be applied to the network. So the PACE architectural design, as I said before, it takes the MARE security plane. From the ASPO, we take the candidate security functions and playbooks. From the security function composer, we get the compose security function. From the security SLA manager, we get the policies and the acceptance criteria. And from the telemetry, system characterization, and attack surface identification, we get all the metrics, baseline threat models, and we need to evaluate. From there, PACE evaluates the test environment that will be used. So the validation context could be, as we said before, a simulated context, such as network simulator or OMNET or any other simulators that exist. Emulated context, basically network digital twins based on Open5GS, Free5GC, Eurasim, also combination with real RAN. Okay, or real infrastructure testbeds, such as commercial 5G or beyond 5G implementations, or a Microsoft, let's say, 5G real infrastructure. And from then, having decided on the validation context of what will be the environment, and in combination with the testing environment management that builds the network architecture, we test and pre-assess the security function. And as a result, we give an assessment verdict. So it will be either to deploy the security function to the network in order to have, let's say, mitigation actions or any other sort of actions in case of an attack, or to prevent an attack. And also the impact and compliance. So in order what will be the impact of the security function in position in the network, and if it complies mainly with security service level agreements and the SLAs, such as like the quality of service, quality of experience that needs the, let's say, the network to exist after the security function is applied. This is sent back to the adaptive security policy orchestration as a decision loop to take the final decision if the security function composer, as has been composed by the SEPA, is applied to the network. So the key scope of the PACE, let's say, component is that every candidate mitigation or preventive security function is validated in a control environment before it is enforced on a live infrastructure. So the pre-assessment loop that is performed is that we take the candidate security functions, So the aspects and security function composer propose the mitigation or preventing security function. We select the context, so the testing environment manager picks the simulation, the emulation, or the real testbed. The test is executed once the scenario and the network architecture is built, so the attack and the security function are played under control conditions. Their impact is assessed, so the pre-assessment validation check that the security level objectives, thresholds, and side effects are adhered to the security service agreements, and this verdict is issued to the cybersecurity core in order to be applied to the network. The validation context that we have considered are three, as I've said before: simulated concept for fast, repeatable, low-risk validation on pre-recorded simulated traces; emulated context, so basic network digital twins that replicate the target infrastructure architecture. They can test various 6G network services, up-and-coming experimental network services that could be applied, offered by the 6G solution. They produce near real-time traffic replication, ideal for short-term prediction. And this gives us a higher fidelity, fully isolated platform for production to perform our tests. And also, as it is really, sort of like the baseline for all the AI and machine learning algorithms that are used in order to produce cybersecurity solutions, security functions. The emulated concepts, so effectively network digital twins, they offer vast synthetic data creation that we can produce a lot of data to train our models based on different scenarios. Finally, we have the infrastructure testbed, that these are real 5G, 6G testbeds, such as Microsoft private 5G solutions, which are used when high confidence is required under safety constraints. So the test environment management selects and prepares the environment in which each security function is assessed. It identifies the environment, so selects the most suitable context. This is also driven by the security function that would like to apply. Then it provides the environment configurations, and so instantiates, parameterizes the network digital twin, the simulator on the physical testbed, and the network topology, the running services, the traffic models. Once this is set, we get the characterization baselines from the system characterization in order to see what is the baseline and what is the drift from when an attack comes. And finally, the pre-assessment and validation decides whether a candidate security function is fit for enforcement. Initially, we have the test execution, so the validation scenario is run. We have the policy-driven evaluation that checks the results against the SSL and the SLO acceptance criteria. These are provided from the interface layer. Then the impact analysis comes that verifies that security function meets its security objective without degrading performance or availability. And finally, the assessment verdict approves the enforcement or requests, approves the enforcement of the security function or requests an alternative security function or dot composition from ASPO in order to produce better results, better, let's say, mitigation results. This is the end of the presentation. I have, if I have a bit of time, I have like a small presentation on some preliminary results on network digital twins.